Welcome everybody, and thank you for attending my session. My presentation is about what actually Android Runtime team at Linaro is doing to improve Android on ARM architecture. And let me start with a short introduction, what actually the Android Runtime and the team are. So it's traditionally, as you can see, the Android Runtime is the important part of the Android and responsible for running managed code. It has most features that modern runtimes have, for example, Java virtual machine. And the art team is a part of Linaro consumer group, which is actually responsible for optimizing the Android runtime for mobile ARM architectures, 32-bit and 64-bit as well. To do this, we need some benchmarking, and our benchmarking, as we have, it consists of two major parts. One is benchmarks itself and the framework. And another part is helper scripts, which we use to run benchmark on devices like Pixel phones and to collect performance data and generate reports on performance data. Not on slide, but we also have a system visualizing benchmarking results. It's part of our CI. And all the repositories are public, so can be accessible from by anyone. And when you do benchmarking, you always should understand what are your targets. And for us, as we're working on optimizing compiler and generated code, targets are the compiler itself, not the whole Android system. And what the code is generated, especially from ahead of time compilation. This mode allows to fully supply almost all heavy optimization, and it's for us it's important to see the quality of the code. And also we are interested in performance on little cores. As you can know, ARM CPUs usually, system on chips usually consist of little cores and big cores. Big cores are more powerful, little cores are less powerful. And for mobile phones, of course, it's important performance on little cores as usual. Okay. So benchmarking Android framework is quite a hard task because we run benchmarks on a phone, and the runtime must be updated if changed. This actually quite slows down the process of benchmarking, because you need to build the whole system and flash it to your phone, and building and flashing it's quite time consuming. And also Android, which is built from the master branch, can be unstable. In this case, your phone simply doesn't boot at all. Our ideal solution, which we currently have, is to have a special Android runtime testing mode when we build only ART and its dependencies, and device itself has a stable ISP version, and we reconfigure it to use the new built Android runtime. Now I'm switching to how these ideas and evolved and implemented in the past, and how they are at the current time, and what we are going to have in the future. So in the past, at the beginning, the goal was to start benchmarking as soon as possible, and the tools and benchmarks didn't have or use a sophisticated API, and you can see they were picked up and ported from different well-known benchmarking suites like Dhrystone, Linaro, and caffeinemark, and even so we ported from JavaScript SunSpider. Also, LLVM benchmarks are a good source for different types of benchmarks, and which also stand for. Another well-known benchmarking suite is benchmarksgame. So it has a lot of, and it allows to test different languages. Quite nice suite. And about the special testing mode. At that time, the simplest solution was like to hack a system linker to allow to use new build binaries instead of the old ones, and it worked really well. And we didn't need to flash to build and flash a new Android every time when we want to check our changes in compiler. And also the big advantage was that Android is based on Linux, and as a part of the system, it provided Linux perf, and this allowed us to reuse a lot of useful Linux perf existing scripts to process performance data. It's quite convenient, and of course we use this. But art has been evolving, and one thing it got was a JIT compiler, and also because of the hacked linker actually sometimes introduced difficult to debug issues. So it was decided to change it to something more stable and reliable. So, and the mode itself was based on virtualization, which is based on change root environment. At some point, Google decided to replace Linux perf with simple perf, and of course, most of low-hanging fruit was picked up and implemented. So we needed something new. The first problem with JIT. Now we always check that we work with ahead of time compiler. We don't assume the default mode is ahead of time compilation. So we explicitly check this mode, set, and guarantee our code produces from ahead of time compilation. The special mode. The change was so big that actually all our benchmarking infrastructure stopped working. We found that we have a lot of hard-coded dependencies on the mode itself, and we had to remove these dependencies to some places where they can easily be changed without affecting the benchmarking framework and benchmarks itself. And we are still working on this. It's quite a complicated process, and I will explain some of these things later in our future plans. We were surprised that actually switching to simple perf wasn't so difficult, and we've got benefits from this because simple perf supports Android applications with managed code and with native code simultaneously and provides good tools to analyze performance data and generate reports. And also, we contributed a new tool, created and contributed a new tool, perf to CFG. As a compiler engineers, we want to see performance data applied to a control flow graph of a compiled program. And we created such a tool, and it's currently publicly available and open source. It's a really nice tool. The problem of finding new opportunities. We started looking at more sophisticated benchmarks, and of course, we looked at existing Java benchmarks like DACAPA, SpecJVM, and math benchmarks, and we got issues to run them on Android. These issues something like those benchmarking suits. They use class loaders so much and reflection which actually does not fit into how programs, Android applications run on Android. And some of frameworks are written so badly, the quality of code is low, and sometimes it's not easy to reuse their code. And of course, the biggest problem is dependencies on Java API, which is missing in Android. You can know that Android still, so major Java API for Android is still Java 8 with some additional features from Java 9. And most of modern Java benchmarks, they moved to the new Java API like 11 or higher. So this actually makes problems to reuse them on Android. Nevertheless, we managed to run those benchmarks on Android. For DACAPA, we managed to run 4 out of 14. For SpecJVM, it was 5 out of 9. And we were surprised that we had less issues to run math benchmarks, maybe because math benchmarks actually have less dependencies on different Java APIs. So the mostly depends on core Java API and implement new functionality themselves. And we managed to run benchmarks for quite a number of pure Java math libraries. The first benchmark suite we analyzed was SpecJVM workloads. It was chosen because SpecJVM benchmarks, because benchmarks developed by Spec organization committee are known, they have quite high quality, and this was not an exception. SpecJVM still a good benchmark for assessing JVM, and even we didn't run all of them. If we didn't run all of them, those number of benchmarks we managed to run helped us to identify new opportunities in Android runtime. You can see most of them here. It's specific. Some of them you can find in Java programs as well, not only in Android programs like array bounds check eliminations, some inlining tuning, loop optimizations, and of course, I think what is interesting for us is auto vectorization. Now I want to say about our future as we see it in our benchmarking. The most important thing is to continue investing in our infrastructure and benchmarking repository. Currently, our repositories are part of Linaro infrastructure, and it's not connected to ISP repositories at all. And if something changes in ISP, we usually see our infrastructure gets broken, and we need to fix our scripts. And we want to we want to move our scripts and functionality to create it based of Android Runtime repository, and work with Google to make them use our benchmarking scripts and framework in their development. So, like, we contributed our new tool first to COG. We know that existing Dakapa benchmarking suite has been updated recently, and it now contains new benchmarks and updated existing benchmarks. So some of the new benchmarks looks interesting for us because they support Android, for example, JMonkey engine, and we would like to use them for analysis and understand what new opportunities exist. Another quite interesting benchmarking suite appeared recently. It's a Renaissance benchmarking suite, which states it's modern open source benchmarking suite for JVM and compilers, collectors, garbage collectors, profilers, analysis, etc., etc. So it contains a lot of benchmarks which are divided into following groups. So we have not tried to run them, but yeah, we have plans. And this may be the most important for us because Java benchmarks, so they're mostly target desktop or servers, and they don't have what actually Android applications have, something like their specifics at startup time, code size, and performance little cores. And we found that there are a lot of open source applications on Android platform. A good source of them are Android and GitHub, and there are very popular Android applications, open source Android applications, and we checked we can run them on clean ISP. They don't need Google services to run, and for us it's quite interesting area to set up to create benchmarking suits, Android specific benchmarking suits. And of course Kotlin. Kotlin currently is first class citizen in developing Android applications, and we currently don't have Kotlin benchmarks at all, and we want to have some of them. And let me finish with conclusion: what we had, what we have, and what we will have. So first, of course, Android Runtime continues evolving, and even it's quite mature, there are still opportunities for optimizations. And Linaro art team is trying to have up-to-date solution for performance analysis, scripts, and continue investing time into making Android great on ARM architecture. And we know we can use Java benchmarks, And we know we have no good Android specific benchmarks, and we are going to work on this. But also, we always want, so any help's welcome, and yeah, especially for Kotlin benchmarking suits. This is all I have to present, and currently I'm ready to answer any questions.
Thank you. I'm checking to see how the chat channels look. Currently, we have no questions. You can put your questions into the chat for 311. And they will remain open through the end of the day. So if after this session you want to put some questions in, that would be fine, or any observations. So it looks like you've covered everything. I don't see any questions coming in. It sounds like you did a great job. Thank you for the very comprehensive session.
I hope people will enjoy it, and yeah, I can say it's benchmarking itself is a very complicated topic, and benchmarking Android is more complicated, but it's really interesting and exciting. And yeah, we always, when we have newcomers like interns, first thing when they try to run benchmarks, they get struggled and don't understand how it's actually possible to benchmark at all this system. And yeah, the Android operation system is itself is an operation system.
Yes, and it's through the efforts of you and the team on ART that we keep ARM, running really well on any Android device. So, thank you for that.
Today, our team lead Sulian has presented our results from this year. So I think it should be available, should record it and available to watch and listen.
Yes, that is a good point. There is a session that has already happened that gives an update on the ART team, which covers quite a broad range of things. So I encourage you, if you're interested in this topic, the videos take about 24 hours a day or so to be on the connect.linaro.org website with under the resource tab. Okay, and with that, we'll close out this session. Thank you again, Evgeny, for your presentation, and we'll take a short 10-minute break before the next session.